Hello, everyone, and welcome to another virtual event from Space Place Canada. My name is Julie Tomei, and I am the chair of the events committee for Space Place. We are very excited to have our event today. Our warm-up event for the eclipse this evening. I've got my fingers, my arms, my toes, everything crossed that the forecast kind of holds off. I know we've got some clouds coming in where I am, but hopefully we will get to see a lovely lunar eclipse in a few hours. But we've got a lovely program for tonight, and we will be getting started in just a moment with our guest speaker, but we do have a little bit of housekeeping to do before that. So first of all, we would like to thank our sponsors. First, our Jupiter level sponsor, MDA, and we have a quick video to share from MDA. Excellent. Thank you. And thank you to Kirsten Van Stone, another member of our event committee and one of our board members at Space Place Canada, for running things in the background for me this evening. We also want to thank our three Mercury level sponsors, Global Public Affairs, Stratia, and introducing our new sponsor, Pratt & Whitney Canada, for their support of our event this evening. All right. So that's our first piece of housekeeping this evening. Our second is a little bit of an ask for some donations. We are starting to really get to work on some exciting things, and that, of course, requires a little bit of funds. So for a donation of $25, you can get a lovely Space Place mask and a card that will give you access to music, planetarium music. And I will put the link to donate in the chat. There we go. And if you do make that donation, please send us an email at chair@spaceplacecanada.ca. Send us your mailing address, because if we don't know where to mail that out to you, we won't be able to send you your loot. Also, if you feel so inclined to make a donation of $50, you will get the mask, the card, and a copy of Bob McDonald's book, An Earthling's Guide to Outer Space. Once again, please send us an email at chair@spaceplacecanada.ca with your mailing address if you make a donation. We do have a few extras of those planetarium music cards that we will be giving out as prizes for trivia questions at the end of the talk this evening. So make sure you stick around all the way till the end. All right. So that's it for housekeeping. We have a lovely guest this evening, Dr. Sara Mazrouei, who is a planetary scientist, an educational developer, and a science communication a communicator rather, with a passion for sharing the wonders of the universe with the public. Her PhD research focused on the recent bombardment history of the moon and links to future sample return missions. Her work has been featured in many media, such as the New York Times and National Geographic. Currently, Sara works as an educational developer at Toronto Metropolitan University's Centre for Excellence in Learning and Teaching. Sara is also passionate about increasing the status of women in STEM as well as equity, diversity, and meaningful inclusion. Sara uses storytelling examples, including the Story Collider and TEDx Down to Women, as a method of sharing her authentic experiences and making science more accessible. So let us welcome Dr. Sara Mazrouei. Hi,
Thanks,
Sara.
Julie. Hi. Really
Welcome.
good to be here in the virtual Space Place Canada.
It's so great to see you. I'm really looking forward to your talk this evening.
Thank you. I'm excited. It's not going to be about lunar bombardment, which is my favorite thing, but it will be moon related.
Excellent. So let's get started. I'll let you start your slides and then we will add them into the stream and you can get started.
Beautiful. And if I don't advance the slides, please do just scream and I will stop and make sure that they're advancing somehow.
Excellent.
Beautiful. And are we good now? You can see my full screen?
I can. Take it away.
Awesome. Thank you so much, Julie, and thank you for the introduction. Tonight, I'm joining you from just outside of Toronto, where we still have a little bit of a cloudy sky. Toronto is in the dish with one spoon territory, a territory between the Anishinaabe, Mississaugas, and Haudenosaunee. As an immigrant and a settler, I'm super grateful to have the opportunity to work, learn, play, observe the skies from here. And as a planetary scientist, educator, I try to learn more about Indigenous knowledge, Indigenous ways of knowing, and the relationship with the sky. And as we talk about lunar exploration, I try to learn from what has been happening here historically and making sure that as we move forward with lessons learned, not to repeat the same tragedies and mistakes. So tonight, I'm going to focus on lunar exploration, a little bit about the past, a little bit about the present, and a little bit looking into the future. Now, just wanted to give you a little bit of an overview, and I know this picture is a little outdated. We still got to add some of the stuff that's coming up in the future years, but I just like it as a big overview. And I know it's really small, and don't worry if you can't see all the numbers, but right at the left-hand side, we start from 1959 with all the lunar missions, and you can see a big cluster in the 1960s, 70s, with the Apollo missions, the lunar missions, and all the hype about all the lunar exploration that was happening. And then you see a big gap until the early 2000s, really 2008-ish, where lunar exploration picked up again. And my goal is to give you a little bit of a flavor of all of these explorations throughout the past 50, 60 years or so. So starting with the crewed Apollo missions, we had them between 1967, 1972. Hard to believe that we haven't been back as humans back to the surface of the moon since then. Total number of people that have flown to the moon are 33 people, and we've only got 12 astronauts that have walked on the surface of the moon. All American men, all around the same age. And that was 50 years ago. So we'll see what the future has for us. But some of the highlights that came from the crewed Apollo missions were obviously to have the first humans to leave Earth's orbit, first humans to land on the moon, and all of that is history at this point, and we know all about it. The landing sites for the Apollo missions all happened on the near side of the moon, the side that is facing the Earth, And, nothing close to the poles or anything, sort of settled for the equator right in the middle and center, trying to make sure that we've got some safe landing. When I was putting this talk together, I was trying to think about, I wanted to highlight some of the scientific discoveries that were made during the Apollo exploration of the moon. So just going beyond that initial hype of, well, who's going to get to the moon first, and like all the technology demonstration. And it's so hard to just pick, 10 scientific discoveries. Really, we've made thousands of discoveries from the Apollo missions. Even to date, we've got samples that have been returned 50 years ago that have been like safely put away in a vault. And every year, kind of like the holidays, it's like a little present. Except, scientists have to write pages and pages of proposals to get a tiny piece of these samples. But that's because, when we came back from the moon 50 years ago, we knew that technology was going to advance, and we wanted to save some of those for the future generations and for when we had more advanced technology, really, to look at those samples. So for tonight, I'm going to focus on just 10 discoveries, but know that there are many, many more, and there will be many more to come from the Apollo mission still. So one of the first things was that before we went to the surface of the moon, we really weren't sure of the state of the moon. We didn't know, if it was almost, was it molten? Was it not? Did it have rocks? Did it have seas? There were some good guesses, but really unlimited speculations of what the moon was really like. We know now from the Apollo missions that the moon is not a primordial object. It's about 4.5 billion years old. It's got a pretty thick crust, about 60 kilometers. It's got a solid inner core, a small fluid outer core, and partial melt around it. It is a world similar to really any of our terrestrial planets that have evolved over time. And the internal layers of the moon are actually fairly similar to the Earth. Not exactly the same, but similar enough. And that's something that we didn't know 50 years ago. The other was that the moon is ancient, and it's got an early history of the solar system in it, really, especially within the terrestrial planets. If you've ever been to a talk where I talk about the moon, I always say the moon is like a time capsule, and that anything that has happened on the moon has stayed on the moon for the past 4.5 billion years. I like to think of the moon as sort of like a museum in space almost. You go in there and there's just so much to see and so much history. And we share, because the moon is so close to us, we share a very similar history here on Earth and the moon. But here, of course, we've got tectonic activities, we've got rain, snow, plate tectonics, and a lot of that history has been erased. Now, the surface of the moon has a lot of craters. And over time, we've used that sort of cratering record to come up with ages and rough ages of things. We know if a crater is overlying another one, it must be a younger event, for example, so on and so forth. Believe it or not, we use the same chronology from the moon to date objects anywhere else in the solar system. So if we look at a system on Pluto, for example, and say this is 1 billion years old, for example, it's coming from the same calibrations from the moon. And the reason for that is that, the moon doesn't have an atmosphere. We have a full record of 4.5 billion years. But really, those Apollo missions, the rocks that came back from the Apollo missions, are only physical samples where we can take them into our laboratories and get some dates for these rocks, for examples, and know precisely how old they are. So if I know that an astronaut has grabbed this from a nearby crater, and I test this in my lab and I do a whole bunch of stuff and I think, okay, this rock is 3.9 billion years, then I can match it to my cratering record and get an age for everything else in the solar system. So really, anything that we know about any ages in the solar system rely on the few samples that we have from the Apollo missions. And that's why going back to the moon, bringing back more samples will help us refine that aging system, and obviously be able to get more precise ages for the moon and for other planets and other activities in the solar system moving forward. The youngest moon rocks are basically as old as the oldest Earth rocks. And this is not a riddle. It's literally the youngest moons on the Earth are as old as the oldest rocks on Earth. And again, that's because on Earth, everything gets erased. So really, even if we find really, really old rocks on the surface of the moon, it would be an equivalent of some of the youngest moon rocks. Even though, the Earth is also 4.5 billion years old like the moon, we don't have any rocks on the surface of the moon that are that old. On the surface of the Earth that are that old, really. But this precise rock sample here, it's one of the samples that was brought back by the Apollo 14 astronauts in 1971. And just a few years ago, it made news that a piece of this rock that came from the moon actually has a piece of an Earth rock in it. And here on Earth, we have folks that go meteorite hunting, they find meteorites, and we find meteorites that have come here from the moon or from Mars. Whenever you have an impact crater, a whole bunch of rocks get excavated. But for example, surface of the moon, gravity isn't as strong, so some of those smaller rocks could escape gravity and eventually could actually land on Earth. Now, a similar thing has happened, but in the opposite direction. We've probably had a cratering event here on Earth. Some rocks have escaped Earth's gravity. They've been captured by the moon, and eventually it sort of evolved into a piece of this moon rock that then our astronauts have picked up and brought back to the Earth. Now, what are the chances of that? Of going all the way to the moon to bring a rock that's actually got a piece of an Earth rock in it? I thought that was pretty neat. It was a big discovery a few years ago, and I thought it would be fun to share that with you as well. Now, the moon and the Earth are compositionally related. They're pretty much made up of the same type of material, just in different percentages, and they're formed from different properties of common sources of material. The moon doesn't have, it's really depleted in iron and some volatile elements that would be crucial for forming an atmosphere. Because of that, the moon and the Earth are a little bit different, but really you can find similar compositions between the Earth and the moon. Something that is very obvious to us today, but wasn't back then, is that the moon is lifeless. There's no sorts of living creatures, organisms, fossils, past, present, nothing on the surface of the moon. And again, before we sent astronauts there, before the Apollo missions, we weren't really sure about that, to the point that when the Apollo astronauts would return to Earth, they would have to quarantine for such a long time in case they had any moon microbes or anything that was stuck on them and that got brought back to the Earth. So, but now we know there's nothing there. There's no source of life on Earth, on the moon. That was never there, and it currently is not there either. All the moon rocks have originated through high temperature processes with little or no involvement with water. And if we had to categorize moon rocks into categories, we could really put them into 3 different types. the surface of the moon is just filled with rocks and regolith or sand. And even when we look at the moon from here on Earth, hopefully we'll get some clear skies tonight and we can look through telescopes or naked eye. You see parts that are darker on the surface of the moon, which we call the mare, and you see lighter features, which we call the highlands. Now, the mare are generally made up of basalt, which is very similar to the volcanic basalt that we have, the oceanic crust that we have here on Earth. You would say they're generally similar or the same, even just by looking at those rocks, they look very similar. And you can really find them in the mare. In the highlands, we've got anorthosite, which is this lighter color rock. They are from the most ancient parts of the moon, and something that is extremely common on the surface of the moon are breccias, which is basically a whole bunch of rocks that have sort of melted and then like mixed and come back together through either cratering or any event on the surface of the moon. So if you were to grab a piece of rock, there's a good chance that you're going to have a big mix, and that's what we call a breccia. Some things that you will never find on the surface of the moon are rocks like shale and limestone, basically the types of rocks that would require water for their formation. So we don't find any of those on the surface of the moon. And if you had to define 3 rocks on the surface of the moon, you would have basalts, anorthosites, and breccias. Number 7, one of the biggest discoveries was that early in its history, moon was in this like molten state. It melted to great depths and it formed a magma ocean, really. It happened about 4 to 4.6 billion years ago. The remnants of those early, solar system days when everything was sort of forming. And at this point, all the more dense elements sank to the middle, and all the lighter elements sort of came up to the surface of the moon, and really impact cratering that was happening at the same time then created these large basins that we call mare. Really, some of the mare that we see from the surface of the Earth. So it's this big, giant magma ocean, and it helped in the way that the elements are sort of set in the moon. Lighter ones are sitting at the top, heavier ones sank to the bottom. And then after the lunar magma ocean, it was really followed by a series of huge asteroid impacts, and that's really something that happened throughout the entire solar system, especially the inner solar system. I like to say in its early days, the solar system was sort of like a soup. Everything was just like swirling around, bumping into one another. So those giant asteroid impacts created these basins that were then filled with lava flow. And those are the darker parts, the mare, that you can even see from the surface of, from here on Earth. Mass of the moon is not uniformly distributed inside the moon. So if I wanted to put the center of mass, I couldn't really put it right through the center. It's actually shifted a little bit by like several kilometers towards the near side, the side that's facing the Earth. So the crust is actually thicker on the far side, while most of those volcanic basins and then therefore the unusual mass concentrations or mascons are on the near side. And that's probably because these basins are filled with these lava flows, which are heavier elements. So if you had to put the center of mass, you would actually have to shift it a little bit towards the Earth. So it's not like a perfect homogenized sphere in space. And number 10, the surface of the moon is covered by a rubble pile of rock fragments and dust, which we call the lunar regolith. And if you watch the first Apollo landing missions, you will see as the astronauts trying to take a step down from the ladder to the surface, there's a little bit of that hesitancy because they're not sure what it's going to be like or how thick that lunar regolith is. But now we know the entirety of the moon is rocks and sand or regolith. No cheese, no microbes, no living organisms, nothing like that. And that sort of brings me to the end of my scientific discoveries of the Apollo missions. We could spend days talking about the Apollo missions and their discoveries, but it was just a little bit of a flavor to remind us of all the amazing things that we've learned about our closest neighbor just from those Apollo missions. And now I wanted to talk a little bit about some present lunar exploration, so things that are happening these days. One of my absolute favorite missions is the Lunar Reconnaissance Orbiter, or the LRO, that was launched in 2009. I could easily say that after the Apollo missions, it's probably been one of the more, if not the most successful lunar mission. It was originally only meant to last for a few years, but with any other great, any great space mission, if the spacecraft is in great shape, if you're still making discoveries, you could put in requests to get an extended mission, and LRO has had an extended mission twice so far. It got launched June of 2009. So what is that now? 13 years, if I'm doing the math right. It's got 6 important instruments. The reason that it's so near and dear to my heart is because I used a lot of the data from Lunar Reconnaissance Orbiter for my PhD research, and I've just seen the amazing things that have come from that. So similar, it has mission goals with any other mission. It is an orbiter. It's been orbiting the surface. It's been orbiting the moon for the past 12, 13 years, or no, 11 years. 13 years. And 24/7, it's just going around, and it has mapped the surface of the moon with 6 different instruments. And the amazing thing about it is that because it just keeps going around the moon year after year, it's allowed us to compare data over years. And we can see things kind of in a live setting. So we can really go back over the same spot and see if anything has changed. And that was one of the mission goals of LRO, was to do a detailed characterization of the surface and the radiation environment, and to identify any resources like water ice deposits that we could then use for future missions. And because of the instruments, the cameras that are on board, it can really identify any landing hazards like rough terrains for future missions. And I'll show you some examples of that in a little bit as well. Again, similar to the Apollo missions, we could talk about LRO discoveries for days. There's been a ton. Some of the really exciting ones are around temperatures. We know that some regions get really, really cold as minus 240 degrees Celsius. The spin orbit of the moon is perpendicular to its orbit. So it's fully sitting at a perpendicular angle. Like the Earth has a little bit of a tilt, but moon doesn't have that. And because of that, a lot of the craters that are sitting near the North Pole or the South Pole, you could kind of imagine like putting a little cup, a bowl, not a cup, a bowl at the poles, and it would really there are some parts that never get any sunlight. And because of that, they can get really, really cold. We call them cold traps. We call them permanently shadowed regions that never see sunlight. We also know that there is water on Mars thanks to the LEND instrument. It can pick up hydrogen atoms. We know that there's water ice on the surface of the moon. We know that the moon is shrinking, Yes, you heard that right. The moon is shrinking. I'll tell you a little bit about that as well. And we've also discovered lunar pits, and I'll show you some examples of that as well. So this is using the diviner instrument on the surface of the moon and sort of doing a maximum temperatures, minimum temperatures at the North Pole. And you can really compare and see how much, like how many degrees the surface really changes. We see some of the more drastic changes near the equator as well, where, you know, the mean surface temperature could reach about like 400 degrees Kelvin at noon, and then drop down to negative almost 300 Kelvin, 100 Kelvin by nighttime. So about a 300 degrees Kelvin difference just from daytime to nighttime. If you thought here, like the weather in May or in February or whatever in Canada is crazy, you don't know what to wear. You know, it's hot one day and it's really cold another. Imagine living on the moon. Like your day and night could be extremely different. I think these sort of some of these permanently shadowed regions on the surface of the moon are actually colder than some temperatures on Pluto, which is so much further from the sun. And again, that's because the moon has no atmosphere, but also because of because of its orbit and its spin axis and how some parts never see any sunlight. Again, because of that lack of atmosphere, that's why you see these massive fluctuations in temperature as well. So here on Earth, our atmosphere really helps regulate some of that daytime and nighttime temperature. But on the surface of the moon, you really don't have that. And outside of Mercury, which is the first planet from the sun, again with no atmosphere, you could say that you see the most drastic changes in temperature on the surface of the moon. And this is a picture of the South Pole region of the moon. We have Shoemaker, Crater, Faustini, Cabeus, and the blue is sort of showing you those permanently shadowed craters, which are those perfect places for water ice to exist. And we'll talk a little bit about the upcoming Artemis missions. But the South Pole has a very special, it's very special for exploration. It's really like the hot spot for discovery, really. I mean, if I had to put my money of where we're gonna go, you know, to really discover if we want to find those, you know, water ice and sort of resources for future exploration, I would put my money near the South Pole. I think that's a really great place to go for discoveries. Now the moon is also shrinking. Remember we talked about that whole magma ocean, about everything being molten, and as everything cools down, it also shrinks. You could say about like 50 meters in the last several 100 million years. So it's really not that much when you think about it, but it is. And we found evidence of this using cameras on board the LRO. You can kind of think of it as a grape. You know, as it starts to lose some of that moisture, it turns into raisins and it gets all that like wrinkly skin. But the surface of the moon doesn't have that elasticity to sort of wrinkle, so it sort of breaks and it gives us these fault structures that is an indicator of the interior of the moon cooling down or the moon shrinking. And then we've also discovered these lunar pits. At first glance, they look like a crater, but because we can look at it from all these different angles, they actually look like these lava tubes that we have here on Earth as well. This one is an example from the Mare Tranquillis pit, and the pit diameter is about 100 meters, and it's about 100 meters deep as well. And we think, you know, eventually could they really be like a great spot for astronauts? Because we know when we talk about lunar exploration and going to the surface of the moon, one of our hesitations is always radiation, the amount of radiation, the fact that there's no atmosphere, what is going to happen. So could this be a good hiding place? Maybe. It could be something that we look into in the future. And as I said, the LRO has been orbiting. It's given us amazing data coverage of the near side as well as the far side. And it's given us topographic maps. They're extremely detailed, a combination between the topographic maps and just the optical camera. We can really map out anything on the surface of the moon. You can see rocks as small as like a meter in diameter, in size. And really, I spent the summer in an internship really mapping out routes for the next lunar rovers, because you can see the slope, you can see what rocks you've got on your way, you can see all these exciting material that you might want to pick up and all these features. So really, when we go back to the moon, it will be a different story than when we went blindly 50 years ago, not knowing anything. Now we know so much, and we can really have these great scientific questions that we want to answer the next time that we go back. Also, if you've ever been to any of my lunar talks, I have to show this video. And it shows the landing site of the Apollo 11 mission as it's been taken by the LRO. You can see the modules that were left on the surface of the moon. You can see the TV camera. The seismic package that's been left on the surface. Remember I said whatever happens on the moon stays on the moon? Literally, it's been there. I can't leave anything outside my house for more than 2 days. This is my favorite. Tracks that were created by astronauts on the surface of the moon. Like, we can pick that up by this orbiter. And I think this really goes to show you, the amount of details that you can see from LRO. And again, traces from Apollo 17. You can see the moon buggy tracks, the astronaut footpath, the flag that was left there. Really, everything and anything. It just blows my mind every time I look at these. That we can really look on the surface of the moon and see everything that we've left behind. And lastly, from LRO, one of my favorite images, an Earthrise. So this is just showing up the Earth coming up, and the LRO has captured the surface of the moon and the moon coming up. It is a real photo, and it's just so beautiful. We're so used to seeing sunrises and moonrises, but never an Earthrise. So I thought that I would also share this image. Some of the other stuff that has been happening that's really exciting, we've got a lot of different countries involved in lunar exploration nowadays. Changi 4 landed in a crater on the floor of the South Pole Aitken Basin on the far side. So no other lunar mission has ever been to the far side. This was the first, and it happened in January of 2019. Private sectors are getting, into lunar exploration. This was the Israel that was the Israel mission that was selected by the Google Lunar X Prize. Unfortunately, it had a crash landing on the surface of the moon, but the fact that it made it to the surface of the moon in April 2019, I think is so amazing. And then India has also sent a couple of orbiters. They also sent a lander, Vikram lander, but unfortunately it never gave any signals back. So the orbiter did find the lander. It did land on the surface of the moon, but it was not a successful landing because it wasn't able to communicate back with the Earth. And really here, I'll just leave it on the screen for a second to show you, surveyor missions, Apollo missions, Luna missions, all the Changi missions, and sort of all the different countries that have been involved in lunar exploration. Almost all on the near side, except for one that was on the far side. And now future lunar exploration. We've got a lot more people involved. It's no longer that like competition just between the Soviets and the US of who gets to the moon. There's a lot more collaboration. There's a lot more missions, and everyone's putting an instrument on each other's missions, which is really beautiful. And just a little snippet of some of the stuff that are coming up. South Korea is going to have its first orbiter in 2022. It's called the Korea Pathfinder Lunar Orbiter. So this year, they're sending an orbiter for the first time. Russia is going back to the moon with Lunar 2025. It will be a lander on the surface. Things are a little bit iffy in the Russian space exploration world right now, but hopefully they will be able to send this. Japan is also sending a lander, orbiter, smart lander for investigation of the moon in 2023. And India is also planning to send another orbiter and a lander, but we don't know much details about it yet, but it is happening, and China is obviously still in the play as well with their Chang'e 5, 6, and so on. Now, a little bit about future lunar exploration. As we talked about, Apollo, we've learned so much from the Apollo missions. But I feel like every time I give a talk about the moon, everyone's like, "Oh, why do we want to go back to the moon? We've been there, done that. Let's go to Mars." But I feel like the Apollo era was just the beginning and not the end. There's still so much. There's still so much to learn about the surface of the moon. And like I said before, it was more of a technology demonstrator, or being more like, oh, we don't know a lot about the moon, let's go and explore. But now we have so much data that we've been able to form so many good questions, things that we still don't have the answer to. And the moon is our closest neighbor. The more we can learn about the moon without, all of its history being erased, the more we can learn about the Earth as well. So really, the moon also gives us a great opportunity to, we've got this great sandbox, our playground in our backyard, and we got to go there and we got to test things before we move forward to Mars and so on. And of course, NASA's big plan is, moon to Mars, or, Earth, moon, and Mars, really. So we've got the ISS, we want to go to the moon, and then eventually we want to move beyond and go to Mars. I won't go into too much details because, these types of spacecrafts are not really, my specialty and my forte, but I know that NASA is sort of getting its Orion spacecraft ready. It will be what will take the next humans to the surface of the moon, or to the orbit of the moon, eventually to the surface. And it can fit 4 people inside. It will sort of launch with the Space Launch System, the SLS, and there will be a whole series of tests. But the next big thing that you may have heard about is the Lunar Gateway, which will be, I kind of like to call it an ISS, but in the orbit of the moon. So it will allow astronauts to get further from the Earth than ever before, to sort of sit there and observe the moon and be able to control things on the surface of the moon, which will all be new and exciting. Canada's contribution to the Lunar Gateway is our specialty, a Canada arm. We're calling it Canada Arm 3. It will be a smart robotic system. And this Lunar Gateway will sort of act as a laboratory for us to test a lot of stuff outside of the Earth's gravity. We're learning a lot from all these experiments that we're running on the ISS, and this will allow us to test things in a different setting and really be ready for some of those future explorations. So it will be our scientific laboratory. It will let us test a lot of new technology, the whole rendezvousing at different places and being able to sort of act as a mission control for things on the surface of the moon. Now, the Artemis program is going to be in 3 stages. The Artemis 1 will be an uncrewed test flight of the Orion, so similar to the first Apollo missions. We've got it's set to launch on the Space Launch System rocket in 2022 this year. We've got Artemis 2, which will be the first ever crewed test flight on Orion, happening sometime in 2024. So this will not be a lander. The astronauts will not land, but they will be on board Orion. And then we've got Artemis 3 that will land the first woman and the first person of color on the moon by 2025. So really, we're only 3 years away from getting humans on the surface of the moon, and I really can't wait. Now, thanks to our Canada arm, sort of in return for that contribution, Canada is going to get a range of opportunities to do lunar science, technology demonstrations, commercial activities. So we get to send a bunch of experiments. We also get 2 astronaut flights to the moon, and a Canadian Space Agency astronaut, a CSA astronaut, will be part of the Artemis 2 mission. So that's been the promise so far, which is pretty exciting. And I'm going to end on a short video to sort of leave us with a little bit of inspiration and looking forward to these missions.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible. Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
And more in testing.
this system is capable of being the catalyst for deep space missions.
We need a capsule
that can support humans from launch
through deep space and return safely back to Earth. For this, we built Orion.
This is NASA's next generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable,
that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits
It will balance between the Earth and Moon's gravity.
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
To prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and onto Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going.
We're going.
All right. Well, I hope that left you with a little bit of an awe about what's coming up.
Thank you, Sarah. That was awesome.
Thanks, Julie.
All right, folks. So if you have any questions for Sarah about anything that she covered this evening or anything moon related, please go into the chat in YouTube and pop your questions in there. We do have a question from Henry. He says, read some fascinating commentary that I thought was credibly sourced, but about the positioning of the moon in Earth orbit. Could the moon have been able to find a sustainable orbit further or closer to Earth, I assume, is the question.
That's a great question. I feel like it probably may have been able to, but because of its size and its composition, it's probably at its most stable. It is moving a little bit over time. That orbit is shifting a little bit, but we can definitely find some other stable orbits, and that's how we're able to put some of our satellites in the Earth orbit. But really, it depends on like how fast things are spinning and moving. But I think for a moon our size in our solar system, it's probably at its best place. If there were other orbits that were as stable, then we may have been able to have multiple moons like other planets. So that's my best guess.
Awesome. So because we always see the same face of the moon, I think a lot of people assume that the moon doesn't spin on its axis.
Mm-hmm.
Can you talk a little bit about that?
Yeah, so it's pretty neat. I always thought like, why can't we see both sides? The moon does spin, but the rate of time that it takes for it to spin around its own axis, and then the rate that it takes for it to orbit the Earth are sort of locked and synced just in the way that it was formed. And that's why we always see the same side. We always see the same side. But here on Earth, for example, our daytime, nighttime is 24 hours. Our year is 365. So we've got different rates that are not sort of locked in sync together. But for the moon, we're so locked in that we only see that one side.
You mentioned in your talk that the inner composition of the moon is kind of like skewed, like the crust is thicker on one side, and it's got more like heavy stuff on the other side. Would that explain that locked orbit that the moon has?
It could have been, because whatever, these are all things that happen earlier on in its formation, just when the moon was forming and the Earth was forming. And it probably did. I mean, there was so much happening back then, it was molten, things were bumping into it. And at one point or another, one of those could have really led to it. Now, because of that gravity that we have, but also because of all of those basins, we've got them filled with lava and they're a lot heavier. And that's why we've got like the difference between the thickness of the crust of the moon. But yeah, I mean, all of these things really happened like billions of years ago. It's not things that have changed recently. So it all has to do with its early formation days.
All right, we've got another question in the chat from Mike, who asks, is there still science left to be done on the moon, or is now just a gateway point for future solar system exploration?
That's a great question. I feel like there's still so much science to be answered. I often get questions like, well, how was the moon formed? And we've got some ideas, we've got some really great ideas, But at the end of it, we're never really sure because we don't have enough data yet. One of the things that we talk a lot about when it comes to the moon is, for example, the late heavy bombardment period. So about 3.6 to 4.1 billion years ago, we think that the moon went through this period where it was just getting bombarded by all of these massive asteroids, creating all of these big craters, for example. But that's just an idea. It's just because we don't have we don't have the oldest rocks that we've brought back, all the rocks that really we've brought back from the Apollo missions are more or less around the same age range. So we haven't been able to get a full spectrum of rocks from those different ages. So really bringing back physical samples that we can take into the labs and get accurate dates for will really help us define what happened. Was there a whole bunch of stuff that happened, or is that still like a hypothesis that we're not sure about? And then that will tell us a lot more. Here on Earth, we always think about events that have happened in the past, and it's like, well, did something trigger it? Like we talk about dinosaurs going extinct, for example. What happened? And then it's the same thing going backwards in the history of the Earth, but we can never find those answers perfectly on Earth if we're going back in time. So that's why we gotta sort of look to the moon for those answers. And even until before the Lunar Reconnaissance Orbiter, we didn't know for sure that we had water ice on the surface of the moon. Now, our data from orbit show us that we do have that, but to physically go there, to be able to see how that water changes over time, can we use it for fuel or for oxygen or whatever, those are all things that we literally need to go and test out. So there's so many questions, and my vote is to sort of go there and test it all out.
I also vote for more science. I always find it interesting whenever someone says like, nah, no, we're done. Science is done, right?
They're done that.
It's never done. There's always more questions. All right, another question from Henry, who says, the other factoid from my assumedly credibly source is that the weight of the moon was less than we would expect from solid object. Can this now be explained by the frozen liquid below the surface?
I would need to see that source and to read it. There's a lot of stuff that's coming from the source, Henry. I really don't know. I mean, I don't know what's up with the weight of the moon and how it would have changed. It could have been that the material that we thought the moon was made up of was different than what we've actually discovered. But without reading the source, I can't really comment on it too much.
That's fair. All right, folks, if you have any more questions, pop them in the chat. Here's another one. Henry is full of questions this evening. Is a full-scale drilling program to go very deep feasible for the moon? And do you think we could get some more big surprises?
That's a great question. I think it's absolutely feasible. I mean, we are doing the same thing on the surface of Mars. A lot of our missions, or some of them, have drills that are sort of getting those drill cores out and those samples. So in terms of like the technology feasibility of it, it absolutely is. Could we find something new? Probably. I feel like right now, with the data that we have from orbit, we have a good understanding of what type of material are where and like how much of them. But really, to be able to go there and dig and see what's in there, we could be left with surprises. We could be able to sort of go back into the history a little bit and see what's underneath as well. And it will tell us a lot more about the formation of the moon, about the type of rocks that we have, and how well things preserve. So if you have a layer of dust that's sort of blocking things underneath, what's really happening to the material below? So that would be pretty cool.
Of course, the second you start talking about drilling, people start thinking about mining, but we'll save that as a topic for another day.
Yeah.
All right. So again, folks, if you have any questions, stick them in the chat. While we're waiting to see if there are any more questions, I'm going to remind you that if you make a $25 donation, you can get a mask and a card with access to music from the McLaughlin Planetarium. And that if you make a $50 donation, you get the mask, the card, and a copy of Bob McDonald's book, An Earthling's Guide to Outer Space. I will put into the chat the the link where you can make that donation if you feel so inclined. And if you do make a donation, we need to know where to send your loot. So please make sure to send us an email at chair@spaceplace.ca. So we know where to send you that through the mail. All right. So it looks like we don't have any other questions. So it is time.
I do have a fun fact-ish.
Oh,
I'm
sure.
just trying to think. I can't remember. I mean, I'm trying to see if my memory serves me right. But I think it was a few years ago that amateur astronomers discovered a new impact crater on the surface of the moon during the lunar eclipse. Like they watched it happen live, right? Am I right? Is that memory serving me right?
I don't remember that, but that sounds awesome. And I'm sure that Google or your other search engine of choice will help you find that, folks, if you want to go find that. I trust Sarah's memory, though. That sounds awesome.
It did happen during an eclipse. People did watch it, like they got images of it, and then the Lunar Reconnaissance Orbiter eventually did find the spot, and they're like, yep, it did happen. I mean, what are the chances? But just something to look for tonight. Where I mean, it's kind of clear, kind of not. So maybe
there's a few clouds up where I am, but I did take a peek close to the end of when you were wrapping up your talk, and it looked like there was still some sky up there. And Kirsten did some quick Googling, and it looks like it was the 2019 lunar eclipse. She put a link in the chat to space.com article about it.
Yeah. It was in the before times. That's why,
Yes, the before times. Okay, time for trivia. All right, folks. So these are multiple choice questions. We'll be awaiting your answers in the chat. They are for the cards that will give you access to planetarium music. Whoever puts their answer into the chat first will be the winner of the card, and then we'll simply ask you to send us an email to chair@spaceplacecanada.ca to send us your mailing address so we know who to send the card to. Okay, so here is the first question. The color of the moon is A, about the same as that of worn asphalt, B, similar to that of blue cheese, C, light gray, or D, metallic. That's no moon. Waiting for some answers. I did have some fun.
I feel like we need some music, you know?
Do, 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 do. Oh, wait, that's probably, we probably can't sing that one. Okay. We've got an answer of C. Any other answers? I'll wait for some more answers. Susan, yes, it is in fact A. The answer is A. It is about the same as that of worn asphalt. So a little darker than you would think, given how bright the moon appears in the sky, and especially how bright it appears through a telescope.
Yeah. I feel like that was a trick question.
I mean, no one said D, so I'm glad about that one. All right. Don't worry, folks. If you didn't get this one, I've got more cards. I've got more trivia questions. All right. Next question. What was the first spacecraft to land on the far side of the moon? Was it A, Luna 14, B, Chang'e 4, C, L-Cross, or D, Chandrayaan 2?
Everyone should get this. We talked about it.
How much were you paying attention to Sarah's talk? Very good. Rachel was paying attention. It was Chang'e 4.
Hey.
All right. Congratulations. Okay, I have even more cards and even more trivia questions. Pink Floyd, huh, Henry? All right, here we go. Which geologist's ashes were sent to the moon? Was it A, Tuzo Wilson, B, Charles Richter, C, Marie Tharp, or D, Eugene Shoemaker? There's no penalty for guessing. Ah, good job, Victoria. Yes, it was Eugene Shoemaker.
I had no idea, but if I had to guess, I would have guessed D.
All right. Yet another question. Ready? What is the largest crater on the moon? Is it A, Tycho, B, Copernicus, C, South Pole Aitken, or D, Fra Mauro?
Fun fact, my dog's name is Tycho.
Nice. He does have a nose, right?
He does, yes.
I've got my son next to me trying to guess the answers. Oh, Rachel guesses D. It is not D. It is not A. It is not B. That only leaves one answer. Oh, that was a tough one. It's okay. It's all right, folks, because I do have one more trivia question. Here we go. What is the name of the space station that NASA and its partners, including the CSA, plan to put in orbit around the moon? Is it A, Artemis, B, Lunar Gateway, C, LSS, or the Lunar Space Station, or D, Babylon 5?
Who came up with option D is what I want to know.
Me, of course. Good job, Rachel. It is, in fact, B, Lunar Gateway. You were paying attention. Woot, woot. Yeah, I had some fun coming up with answers. It's like, who remembers a television show from 25-ish years ago? All right. So we have only one thing left to do. So those of you who answered the questions right, please don't forget to send an email with your mailing address to chair@spaceplacecanada.ca so that we can send you those cards. So for those who are peeking up the window, whoa, I see clear sky. So the eclipse tonight begins at about 9:30. Any tips for eclipse viewing, Sarah?
Find a patch of clear sky with the moon.
That is
in
a
it.
good first tip. Find a patch of clear sky.
Yeah, find clear skies, preferably somewhere where you don't have tall buildings and trees getting in your view. My tip is to just like sort of go in and out. I mean, you could watch it for 5 hours if you wanted to, but you could take breaks and then like periodically go back out and you could see bigger differences.
Yeah, it is unlike a solar eclipse. There isn't one of those like you must be there at exactly this time or you'll miss it. Lunar eclipses are fairly long affairs. This one starts at about 9:30, where you're just gonna start seeing a little bit of the moon starting to get into the lighter part of the shadow of the moon. Totality will be starting at about 11:30, and it will continue until just before 1 a.m. So you've got a good chunk of time. If you are, I don't know, busy doing something else, whatever your busy lives entail at 11:30, it's okay. You can go out a half an hour later. And then the moon will move out slowly the other side of the shadow, and the eclipse officially ends just before 3 a.m. So it is a fairly long thing. It's mostly about being comfortable. Maybe bring a sweater if it gets a little chilly outside, some bug spray if it's buggy, a chair. Chairs are good. One that reclines a little bit. Because eclipses happen during a full moon, and this one starts around the time that the sun is just a little bit after sunset. You're going to want to be looking to the east, where the moon's going to be rising, and where you're going to be looking is going to be moving as the moon continues to rise. If you have binoculars, sure, why not get a closer look at some of those craters, but you don't really need anything special to observe these. There's no safety equipment needed. They're really, as far as astronomical events, pretty easy peasy, which is nice. All right. Do you have anything else to add, Sarah?
No, just enjoy. I think here I was just trying to peek at the forecast. Some rain might be coming in around 10:30ish, so even if you can catch the beginning of it, it will be nice. And then I think you were going to share some links for people to observatories, right?
Yes. So I realized that not everyone tuning in tonight is necessarily in the GTA or even in Ontario. So our friends over at the Alan I. Carswell Observatory at York University are broadcasting the event tonight. Hopefully the clouds will cooperate with them as well. So if you want to head over to their YouTube channel, just go, well, you're already on YouTube. Just search up Alan I. Carswell Observatory or York Observatory, and you'll find their channel. I think they're starting their broadcast at 9, and they will be showing what they can. And thank you very much, Kirsten, for throwing the link in there. And we are going to be having another event this coming Thursday with Elizabeth Howell about her book, Collaboration, Canadarm and Collaboration. So we'll have a few links to tonight's talk, I'm sure, because we mentioned Canadarm 3 and the CSA. So if you are interested in that, you can head over to our website, spaceplacecanada.ca, for links to register for that. So thank you, everyone, for tuning in this evening. Thank you so much, Sarah, for a wonderful talk. And we will see everyone soon. Thank you. Bye.
Eclipsing.